All right, so today we're diving into something really driving the AI
What's
revolution.
driving it?
And no, it's not just, those brilliant minds out there building these things.
Right.
We're talking about the actual hardware, like the unsung heroes. GPUs,
Yeah, GPUs.
specifically the fact that there's a global shortage of them.
Yeah, it's a big deal in the AI world.
Yeah, it's a huge deal.
Huge.
And, since you're interested in AI, I knew we had to unpack this.
Oh, yeah.
Because even if you aren't, building these complex systems,
Right.
this shortage, it affects everybody.
It does.
It affects development timelines.
Absolutely.
It affects what's even possible.
It really does.
So,
Most people have no idea how different these chips are
okay.
from the CPU.
Yeah.
You find it in your computer.
Yeah.
Completely different way of processing.
Okay, so for those of us who, didn't grow up building computers,
Yeah.
what are GPUs and why are they so crucial for something as complex as AI?
Okay, so imagine this. A CPU is like a master chef
Okay.
trying to cook a 1,000-course meal alone.
Okay.
They can do it, but it's incredibly time-consuming.
Right.
Now imagine that same chef with a team of hundreds,
Okay.
each perfectly specialized.
Okay.
That's a GPU.
So instead of one super brain trying to handle everything, it's more like a massive coordinated effort.
Exactly. GPUs have thousands of smaller cores that can process information in parallel, making them ideal for handling these huge data sets needed to train AI.
So is that
Think of it like this. Training a large language model is like teaching a computer to read every book in the Library of Congress.
Wow.
A CPU would be painstakingly slow.
Yeah.
But a GPU, with its parallel processing power, can churn through that information exponentially faster.
Which kind of explains why everybody wants them.
Exactly.
But why is there a shortage? Were we just caught off guard by this whole AI boom?
Well, demand has skyrocketed, that's for sure.
Okay.
Every time a new AI model is developed,
Yeah.
it seems to be bigger and more complex than the last,
Right.
requiring even more processing power to train.
So it's not just that we need more GPUs.
Right.
It's that they're becoming more powerful and like harder to make.
It's a bit of both.
Okay.
To give you an idea.
Yeah.
Training a top-tier AI like GPT-4 is estimated to have cost around $78 million, with a significant chunk of that going towards pure computing power.
Oh, wow.
Google's Gemini Ultra model reportedly cost even more to train, nearly $200 million.
Goodness.
That's a lot of processing power, and it highlights the scale we're dealing with.
Yeah. Yeah, those numbers are pretty mind-blowing. It's like the cost of a skyscraper.
Right.
But instead of steel and concrete, it's all computing power.
Yeah.
But let's shift gears a bit and talk about the ripple effects of this shortage, because it's not just about the money, right?
Absolutely not.
What does this shortage actually mean for the development of new AI applications? Were we talking delays, roadblocks? What's the reality here?
Think of it this way.
Okay.
Every field touched by AI is potentially facing delays because of this bottleneck. For example, in healthcare, researchers are using AI to develop personalized medicine,
Okay.
analyze medical images with incredible accuracy, even discover new drugs.
So those life-saving advancements we keep hearing about,
Right.
they might be stalled because researchers are literally waiting in line for a GPU.
In a nutshell, yes.
Wow.
And it's not just healthcare.
Right.
Self-driving cars, robotics, even things like personalized education.
Wow.
All of these fields rely heavily on AI, and that development is being constrained by this shortage.
Yeah, that's a pretty sobering thought.
Yeah.
And it makes me wonder about the bigger picture here,
Sure.
the global AI race.
Yeah,
You mentioned that's being affected too.
absolutely. The US, China, and the European Union are all investing heavily in AI.
Okay.
And access to GPUs has become a strategic advantage in this competition.
Because if you control the supply of these chips, you essentially control who gets to build the future of AI.
Exactly.
Yeah.
Which is why we're seeing governments implement policies to boost domestic production of GPUs and secure their supply chains.
Wow.
It's become a matter of national security for some countries.
Wow. So the stakes are incredibly high.
They are.
And speaking of high stakes, let's talk about the economic impact of all of this.
Sure.
I imagine this shortage isn't good news for our wallets, is it?
Not really, no.
Yeah.
The basic laws of supply and demand are at play here. Limited supply plus surging demand equals skyrocketing prices.
So it's not just who can get their hands on these GPUs,
Right.
but who can even afford them in the first place.
Precisely. And that's creating a challenging landscape,
Yeah.
especially for smaller startups and research institutions. Even Nvidia, the leading manufacturer of GPUs, has seen the prices of their top-tier models, like the H100 and A100, increase dramatically.
So where do we go from here?
Right.
Is the solution simply to build more GPUs? Or are there other avenues being explored to address this bottleneck? It's like we're hitting a wall, right? Like a hardware wall. But
Yeah.
I imagine the AI world isn't just sitting back waiting for more GPUs to pop up, you know?
Yeah, you're right. Necessity is the mother of invention, as they say.
Right.
So while increasing production is crucial,
Yeah.
there's a lot of really cool research happening to find alternative solutions to this bottleneck.
So what are we talking here? Are we ditching silicon and like moving on to algae?
Not algae, but, thinking outside the box for sure.
Okay.
One really promising area is the development of completely new types of AI chips. For instance, researchers at Stanford are creating chips specifically designed for AI workloads.
So not just a faster GPU, but a completely different approach.
It's about working smarter, not harder.
Okay.
These new chips are designed with energy efficiency and scalability in mind.
Okay.
Remember, we were talking about the massive energy consumption of training these large language models.
Right.
These new designs aim to significantly reduce that footprint.
So it's about making sure that the AI revolution doesn't, come at the cost of the environment,
Exactly.
which makes a lot of sense.
Yeah.
So if they're so revolutionary, why aren't they being used already?
Well, developing new technology takes time,
Right.
especially something as complex as computer chips.
Sure.
It requires significant research, testing, refinement
Yeah.
before it's ready for mass production.
So it's a marathon, not a sprint.
Exactly. But the potential is huge.
Okay.
This kind of innovation could lead to a future where AI development is more sustainable, more accessible, and maybe even less reliant on these power-hungry mega models.
Less reliant on these mega models. Does that mean the future of AI might actually be about getting smaller?
It's an interesting thought, isn't it?
Yeah.
This shortage might be the push we need to explore different approaches to AI development,
Okay.
instead of always aiming for bigger and more complex models.
Right.
Perhaps there's potential in exploring smaller, more specialized AIs,
Okay.
designed for very specific tasks.
So instead of one AI to rule them all,
Right.
we might have a whole ecosystem of smaller AIs that are each a master of their own domain.
Precisely.
Yeah.
And that kind of diversification could have some real advantages. It could lead to more targeted and efficient applications, making AI more accessible to a wider range of industries and businesses.
This has been a fascinating deep dive.
It has.
We've gone everywhere from the technical parts of GPUs to the global implications of this shortage
Yeah,
and this potential for innovation that it's sparking.
absolutely.
So as we wrap up, here's something I want you to think about.
Okay.
If access to these powerful GPUs continues to be a bottleneck, how might it reshape the future of AI? Could it lead to a fundamental shift in how we think about and develop artificial intelligence? Keep those brain cells buzzing, and we'll be back next time with another deep dive into the world of innovation.